The most important thing is that we learn that in the digital system, for transferring data, we use the signals, digital or analog signals. So these signals that contain the information and data and transfer this data from one point to the another point not only contain the data, besides of this data, our signal has noise. So today I want to talk about the noise and random data and why we learn this topic, because in the next chapter we will see that how can we transfer a data from one point to the another point, and we will see that during this process we will occur and face with the different types of noise, and we will see that these noises are randomly changed. For this reason, we need to learn the concept of random data. The first question is that how can we produce or describe a random noise? Using probability, we can do that. You know that in the probability, we can describe a random data. In fact, probability, ihtimal, is a mathematical tool that we can describe, interpret, and predict the statistical behavior of random events. So, first of all, we need to generate the random number. Generate, yaratmak, a random number. Why we have to do that? To predict and describe them. Actually, if I can describe a random number, it means that I can describe the noise. Okay, for generating and producing a random number, we have two common generators. The first one is uniformly distributed function. And the second one is Gaussian random number generator. Now, when we talk about the noise, we know that it is unpredictable. When something is unpredictable, it means that for describe that we have to use probability. So, for knowing about law of probability, for modeling the random data, it can be useful that we learn the elements of probability. As you see here, the first element is experiment, which is an activity that produces unpredictable result. Unpredictable result. The second one is outcome. This outcome indicates the possible results that the experiment can produce. The third one is random variable. Random variable is a rule that assigns a numerical value to each outcome and typically is represented by uppercase letter like X. Like X. Capital X here is random variable. The next one is event. The event is a numerical condition of the random variable and normally indicated with a square bracket, as you see here. The meaning of this phrase is that a random variable X produces positive value. Produces positive value. If I write the event like that, it means that the Rx, the Rvx, random variable X, produces random number which is equal to A. A is not a random value. This X produces random number which is equal to A. If I write X, capital X, is between A and B, it means that X produces the random numbers between A and B. Produces a random number between A and B. Now, if I write like that, it means that A, B. If I write the event like that, I can represent it in this form. And also A, X, B is represented like that. It means that at this interval, A, for example, at this one, A and B are included at this interval. Here, B is not included at this interval. And here, A is not included at this interval. And the last one is probability measure. We know that the probability can take values between 0 and 1. The probability can take values always between 0 and 1. For example, if I write prob and a variable is equal to 0, I write here an event. It means that this event that I have written here will never occur. because the probability of this event is 0. And if I write prob square brackets is equal to 1, it means that this event will always occur. Because the value of probability is 1. Or if the value of probability is 0.5, it means that this event can occur half the time, 50-50. This is the meaning of these values in the probability. Okay, now sometimes we need to represent the random values for a certain event. So one way of illustrating the random numbers is using histograms. What is the histogram? In fact, a histogram, the frequency of occurrence of a set of random numbers actually. A histogram is formed by defining a set of bins and then counting the number of times falls within each bin. Look at here, this is an example of histogram. These are histograms. This is histogram, and histogram. The difference in this at this one and this one and this one is at the number of bins. How can we use and when can we use from the histogram? Suppose that in a garden you have, I don't know, 18, 19, 100 trees, and you want to represent and know that how many trees height is between 50 up to 100 centimeter, how many trees height is between 100 and 150, and so on. For this reason, I need to use histogram. I divide it between, for example, 50, 100, 150, 200, 250, for example, up to 300. I have, this is the height in centimeter, and this is the number of trees. I say this is a bin. This is a bin. Show that the trees that the heights are between 15 and 100 is 5. I have 5 trees that their heights are between 15 and 100. For example, suppose that this one is 22, I don't know. It means that I have 22 trees that their heights are between 100 and 150. I don't know, 15. And this one can be something like that. Is the histogram of trees of a garden. And if I look at this histogram, I can describe and interpret my trees of garden. Okay, the probability density function denoted mathematically as Pxx. What is the probability density function? When the numbers of n becomes very large, as you see here, the numbers of n becomes very large, the bean size is made small. So the histogram approximates a function called probability density function. Called probability density function. Suppose that I have a histogram like that. I have a histogram like that. If the numbers of n becomes larger, it means that the numbers of beans, this is a bean, becomes smaller. What happened in this case? It means that we can suppose that this actually function change like that, and we can suppose this red one, which is called probability density function, or PDF. Everywhere in the probability you see PDF, it means the probability density function. Probability density function. Now, this PDF is describing with Px of x. X is a random variable and represents the value of random variable capital X at point X. And here also I explain the meaning of probability density function. We said that if the numbers of n becomes very large, it means that if n approaches infinity, it means that our beans, this delta, is represented for beans. This bean approach to 0. So I can define the probability density function. Probability density function. Now, this PDF has some properties. The PDF is greater than or equal to 0 for all x. So Px of x is always greater than and equal to 0, always. The second one, the area under the px of x curve equals 1, equals 1. For example, the area of px, this is my px of x, this area always is equal to 1. The third one is that the probability that x produces a random number which is falls between interval xa and b equals the area under the px curve between xa and b. For example, suppose that my probability density function is like that, okay? But I select the values from A and B, that this A and the B is located here. Now, the probability is equal to area under these 2 points, only the area under these 2 points, because I select my values from A and B. These 3 properties are so important in the case of probability density function. Now, beside the PDF, we can describe random variable but by simpler values which are called moments. Here in this course, we will consider 2 most significant moments. The first one is mean and variance. Mean and variance. You are familiar with these concepts. You know the mean. Mean is the average of the numbers. So, in the case of mean, we can say that, which is represented by mu, is computing the arithmetic average of random number sequences, which are called sample average. We add all of the random numbers together and divide to the numbers sequence. For example, first of all, the formula is like that. Mu of x is summation of xi, I change from 1 to the n, divided by n. Suppose that my x is like that, 0.51, 0.5, 0.4, 0.7. I want to calculate the average. I say that mu x is equal to 0.1 plus 0.4 plus 0.5, 0.7 divided by the number. How many values do I have? 3, which is equal to 3.4. This is the mu of x is equal to 4. The second one is variance. What is the meaning of variance? Actually, variance measure the spread of the random number about the mean value. So the sigma square of x is variance, but the square roots of sigma square, which is represented by sigma x, is a standard deviation, ST, standard deviation. This standard deviation measures the spread of random variables about the mean value mu x and is calculated like that. If we suppose that mu is equal to 0, the variance is calculated like that, and the standard deviation is the square root of variance. But if mu x is not equal to 0, the formula is changed like that. We can write that is equal to summation of xi minus mu x to the power of 2 I from 1 up to the n divided by n. And from here, I can calculate the standard deviation, which is equal to a square root of variance. Look at here. Suppose that in a class, imagine your class, the homework one grades, the homework one grades is like that: 15, 18, 20, 13, 17. This homework maximum grade is 20. 14, 16, 15, and 15. Okay? This is the grades of homework 1. And these grades are the grades of homework 2. 10, 18, 20, 10, 20, 20, 12, 10, 15. Okay? Now, if I calculate the mean value of homework 1, this homework 1 is this random variable name with adding all of this value, 15 up, 18 up to the end, divided by 1, 2, 3, 9 is equal to 15. If I calculate the mean value of this one, again 10, 18 up to the 15 divided by 1, 9 again is equal to 15. The mean value of both numbers that are different with together are the same. But if I calculate the variance of homework 1, which is calculated like that, each value, for example, in the case of homework 1, 15 minus mean value. Look at the formula. Mean value is 15 to the power of 2 plus the second value 18 minus the mean value 15 to the power of 2 up to the end. 15 minus 15 power of 2 divided by 9. If I calculate this value, I can find that the variance will be 0.5 and sigma standard deviation will be 1.87. In the case of homework 2, if I calculate the variance, again 10 minus 15 power of 2 plus 18 minus 15 power of 2 up to the end divided by 9 again. Now if I find this value, I can find that the value is 21. And the standard deviation of homework 2 will be 4.58. If you look at here, you can find that the standard deviation between these two random variables, or here is two homework, is different with together. But the mean values are the same. What does it mean? How can we interpret these values? What does it show? This standard deviation shows that, suppose that here is my mean, okay? If the standard deviation is 1.87, it means that the values, the other values, other grades, more than 70% of values are between 15 plus 1.86 and 15 minus 1.86. Yani are here. All of the other grades. In the case of second homework, the standard deviation is 4.58. It means that the spread of the spread of my numbers or grades are higher than homework one. In the homework one, the probability density function is like that, but in the homework two, the probability density function, for example, is like that. So this random number is different with this random number.